today I'm going to talk a little bit about the Center for Atmospheric Research at the Water Survey and talk about some of the things we do and end with a particular research study that we found some very exciting, surprising findings. So in the center we do a combination of service, climate monitoring, all of these have been talked about here, as well as some applied and basic research studies. The top image on the right is a study that Nancy Westcott and I conducted on fog. A lot of my research is used conducting aircraft, instrumented aircraft that we fly through storms to take observations. The kinds of things that my group is interested in, that I'm interested in, are we want to know how the atmosphere responds to the fact that the Earth's surface is not uniform. And we do a lot of our research in the Great Lakes area because that's kind of the extreme of land, water, and the atmosphere responding to all those variations. The kinds of things we've done here are looking at lake breezes as they move through Chicago, and some other images of reacting to how storms react to the Great Lakes there. Lake effect snowstorms are the big newsmaker for lake types of storms. On the left side, there's an image taken from a recent storm that dropped 10 feet of snow over a 7-day time period. I have no idea where he wanted to blow that snow with the snowblower as he went through there. Lake effect snows come in a variety of forms, either lines. There was a vortex there. You get some very, very interesting storms. But the most common type are these kinds that we see here on the satellite image, which are widespread light types of snow, but they can last for weeks, or at least many days. And the result of these are a great deal of additional precipitation on the east side and south side of each of the Great Lakes. And the red areas that you can see there are generally called the lake effect snow belts. Now the big question is, okay, how are lake effect snows going to react to the fact that the climate is varying? This study a few years ago on the top found that lake effect snows are tending to increase during the 20th century. But outside of the lake effect snow belts, it was almost steady. This study found the same thing in the circled areas just east of Lake Michigan. You see this jump up in snowfall in each of those little time graphs. But to the left of the lake, there was, you saw the lines were basically flat. So from these studies and a number of other studies summarized here, the general thinking is that lake effect snowstorms are increasing, at least the amount of snow is increasing. But interestingly, the reasons that the past studies have given are very different, and they tend to disagree with one another. So there's a big question, why are lake effect storm snows increasing? Where are they? We wanted to look at the Lake Michigan area in a little bit more detail, and we did that by estimating how much snow fell at 3 locations, those red dots that you can see to the right of the lake, how much lake effect snow fell at each of those sites over time. And we did that by subtracting the snow away from the lake effect snow belts. And what we found was a real shock. The top graph on the right, you could see that we did see a general increase in lake effect snows until about 1980. Then it reversed. Lake effect storms since that time were tending to drop less snow. We see similar patterns in the middle of the lake and further to the south. They're a little less dramatic. They tend to occur a little bit earlier to on the southern parts of the lake. So that is a real puzzle. Why are we finding something different? What has happened to make lake effect snow trends reverse? And that's where we are now. We don't know, but it could be, could it be local effects, something to do with the lake stratification, lake temperatures? Maybe the snow is changing to rain. Well, we looked at that, and actually that is not the case. Lake effect rain has been decreasing as well. Maybe it's a change in large-scale atmospheric circulations, winter temperature variations. And so we're really trying to understand that process and seeing what's going on. You can see that there's disagreement on what lake effect storms should do in the future. Some are saying up, some will say it'll decrease. But our observations, as you saw, don't really agree very well with either of those predictions. So we have a lot of questions to answer, but it's a lot of good research. So thank you.